Yeah, we could do that.
What was the intro?
Hey, what's up?
Welcome to Chem Support!
Alright, we have tweets from a bunch of people asking us about a specific lab. We're gonna answer them now. First tweet is from Cheese. We have a lot from this guy, so get ready. How old do you have to be to do titration?
First, you have to understand what titration is. So basically, titration is the process of slowly combining a substance of known concentration with something that's unknown. So you put the known substance in the burette and the unknown substance in the flask. Color indicators are used to show equilibrium when the acid and the base are equal.
Yeah.
When the acid and the base are equal. The volume and the concentration of the titrant or the known substance can be used to find the concentration of the unknown substance. So technically, you can do titration at any age, as long as you're wearing your goggles.
Stay safe, kids. Okay, second tweet, also from Cheese. I'm taking my chem final right now. I need help. It says there's a redox reaction, but I don't know what that is.
So basically, redox reactions are types of reactions where atoms' oxidation states are changed. Reduction and oxidation work together in tandem. So elements that lose electrons are oxidized and elements that gain electrons are reduced. The number of electrons on the reactant side has to equal that on the product side. So in our experiment, titration and redox work together. So the color of our iron solution changed from clear to pink when the KMnO4 was being reduced and the iron was being oxidized. So the titration slowly added in the KMnO4 until the redox reaction reached completion. Our equation was MnO4 reacting with 2+ iron, which produced 3+ iron and Mn2.
Plus.
Alright, third tweet, also from Cheese, is FAS. What do you guys have to say to that?
You shouldn't eat FAS because it's ferrous ammonium sulfate, and that's really bad for you. But you can use FAS to standardize potassium permanganate. In our lab that we conducted, we didn't know the concentration of potassium permanganate, so we standardized it. You can standardize it by using titration. Having a standardized titrant can help us determine the content of something.
Fourth tweet is from Cheese. What's that anime called? Attack on Titan?
A titrant, like we said earlier, is a known substance. It's the thing that goes in the long burette, in this case, potassium permanganate.
Our analyte was the iron tablet dissolved in water and HSO4.
Alright, sixth tweet from Cheese to finish it off. At CVS, your pills are garbage. Explain, how many can I eat?
Okay, so the pills from CVS say that they have 20% iron in them. But actually, that's not true. The pills lie. But how do you calculate the iron content in the tablet?
Yeah.
First, we measured the initial mass of the iron tablet. After we got that value, we then combined it with sulfuric acid and water. Using our standardized potassium permanganate, we titrated the analyte.
Until the color changed.
Until the color changed.
So once the color changed, we knew that our equation had reached completion. So we used the volume of the purple juice, potassium permanganate, to calculate the number of moles in the iron, because we already know the concentration of the titrant, and we just used the chemical equation to find the moles of iron. So once we had the moles, we were able to calculate the mass of iron that was in the tablets, and then we divided that by the mass it had on the bottle. And we found out that it wasn't actually 20% like they said.
Our iron content was roughly 18% in comparison to the bottle's 20%. Is that bad or good?
I'll say it's trash,
I
but
thought that was good to have it close to.
yeah.
It's
Well, the labeling was pretty close, but we were surprised by that because our data was way off from everyone else's.
Our data's trash!
And so are the pills.
Thank you for coming to
Chem
Support!
Cheese also tweeted, guys, help! I drank the purple juice. What's gonna happen to me? Cheese also tweeted, my project is due tomorrow. Help!
Could not be us.